Example 5 is actually one we have already done when we went over module 3, lesson 2. This is example 12. So in example 12, we got the answer here for our half-life to be 24.5 years. Hopefully we get the same thing here. And if you watched that video from module 3, lesson 2, I had two different units. I had years here, and then one of the questions was like, how many will be left after 10 days? And so the unit was supposed to be years on that. Just for clarification, if you watched that video and this video. So example 5 again says the amount of radioactive isotope thorium-234 present in a certain sample at time t is given by A of t, which is in grams, where T is the amount of time since the initial amount was present. So find the initial amount of isotope present in the sample. So the initial amount is at time equals 0. So we use the graph, but you can still just plug in 0 for everything. So we'd get 500e to the negative 0, 28, 28 times 0. Okay, and we can put this in our calculator, but this one with that 0 was really easy. 0 times anything is 0. E to the 0 is 1. Anything to the 0 power is 1, and 1 times 500 gives me 500. So that initial amount is always that number in front of E right there. So we started off with 500 grams. Part B wants us to find the half-life of the isotope. That is, find the number of years until half of the original amount, which is that 500, of the isotope remains. Do not round until the final answer, then round to 2 decimal places. So at my half-life here means that my A of t is 250. So when we solved this 2 lessons ago, we did our equation as our y1, this is our y2, and found the intersection. But now we know how to solve exponential equations, so we can do this one by hand. So I'm going to plug in 250 for my A of t. And now I want to solve for t. So the first thing we do is isolate the exponential. This is my exponential times 500. So I'm going to divide 500 over. So 250 divided by 500 is 0.5. And anytime we're dealing with half-life, it will always be 0.5 equals. If you're dealing with when will it double, then it will be 2 equals and so on. So we have 0.5 equals e to the 0.02828t. Once we have isolated that exponential, now we will rewrite. I can't use this property with an exponential with the base of e. So we will go base to the other side of the equals, which is natural log of 0.5 equals whatever is left, my exponent, negative 0.02828t. And then my last step would be to divide that over. So we've got t equals the natural log of 0.5 divided by negative 0.02828, which is about what? So natural log of 0.5, close it, divided by Rounding to 2 decimal places, we get 24.51 years. Which I don't think it told us how to round on the first one. So we just said 24.5, but you can see we got the same answer by using the intersection method or by solving it by hand.